Okay, um, in this session, I will be introducing the gases, or in other words, just gas in general. I'm going to be covering three main points: what happens with gas, pressure, or temperature, given that we do some changes, some characteristics of the gases, of what will happen, and so forth. But before that, let's recall that the kinetic theory states that the particles in a gas are so small, or in other words, they are very insignificant to their value, and that the particles are also in constant and random motion, and that these particles exhibit elastic characteristic. What does that mean? That when they bombard each other, that there doesn't seem to be any energy loss. Some of the energy will dissipate, however. Okay, so let's keep that in mind. But the three main points which we'll be doing here is that what changes the pressure of gases by changing or how can we change the number or the pressure of gases in three different ways. One will be by changing the number of molecules. That's one. Changing the temperature or changing the volume. Okay. This will just be the introduction to the gases. Eventually, we'll be taking them directly and looking at them as specific gas laws. So, three gas laws will be shown today, but I will not give you which one is which, and we will take them one by one. But we will get to see them. All right. So, what is this that I have at the front? Here at the front, I have a chamber, okay, a container, whatever you want to call it. This is a lid. So we can remove this lid, we can open the lid, make gases come in and out. With this, I can increase the size of the container or decrease the size of the container. So we can do those things here. So let's start with this shape. What is here at the top? There's a temperature. So I want you to keep track of the temperature. I'm going to be using Celsius, all right, instead of Kelvin. So for right now, Celsius is 0 for right now. Pressure, as you can notice that it is 0. And the reason why pressure here, inside here, is 0, that there are no particles. And since there are no particles, then there cannot be any pressure. Okay? As well as temperature. With this at the bottom, this is a heater or a cooler, if you want to say it. How will this help? Well, we will be adding temperature to the container, or we can make it get cool, right? So that we can see the effect of gases. Yes, this is not my bicycle pump. That's okay. So we can have a stopwatch. Okay, we won't be using a stopwatch. We'll be using a width so we can see the width of the container, if it should increase or when we increase it. So let me put the width of the container. Let me give it at 8. Okay, 8 nanometers. Well, it's just a size right now. Collision counter, let me put this in. The collision counter will tell me how often the particles are hitting the walls of the container. The pressure will detect the pressure inside of it, which will be actually detecting the pressure by the particles hitting the walls of the container. Okay, and temperature will obviously record whatever temperature change is happening here. So let's add some particles. Let me add some of these ones here, right? Some of these big ones. So I want to increase some of it by pumping some gases, and I want you to observe carefully how these particles are moving. They're hitting the walls, they hit each other, they pass beside each other, and that's good. That's the way how gases behave, right? That is the gases. So you get the basic concept of gas particles. They're randomly moving, as you can see, all over the place. They may be hitting each other and they bounce back and they bounce back again. Okay, and that is the basic characteristics. So let's start by doing some changes to this. Okay, now as you can see, the first thing that I want to do with this one here is that I want to apply some force. Okay, if the molecules are applying more forces on the walls of the wall of the container, so if these molecules are applying more forces, meaning that they're hitting more the walls of the container from the inside, then we can say that they are exerting more pressure. So let me add on some more particles. Okay, let me put here some particles so that you guys can see how many particles are there. There are approximately 50 particles. So let me add on a few more particles. Right, that's 100 particles. So that's a good amount of particles inside there, although this is just for us to explain it. All right, so as the particles are hitting the walls of the container, notice how the pressure is going. Okay, let's see how often these particles are actually hitting the walls of the container likewise. Right, so the wall collision counter is working. That's telling me that there are about approximately 79 particles hitting the walls of the container. Okay, so these particles now, notice that the pressure is going up, temperature has gone up to 27 degrees. Okay, so you can receive the increase of number of particles, then they exerting more pressure, right? So more particles had more pressure. So that means if you increase the amount of particles of matter inside, there will be increasing pressure. Okay, so let's apply our next concept here. Increasing the velocity of these particles. So let's increase now the velocity of these particles. Remember, we just did that a while ago. Increasing the amount of particles, increase pressure, increase temperature, and the collision as well. So I will be increasing the velocity of these molecules. Now, how am I going to increase the velocity of these molecules if they're so small? Well, we have our magical bucket here. Okay, so I'm going to be applying some heat to this particle or this container, and you will see something about the particles. Okay, and I want you to keep track of the temperature. Look at the temperature, what happens to the temperature up here, what happens to the pressure as I go adding on heat to this container. So I'm going to increase or add on temperature. Notice the temperature is going up, and let's keep it somewhere around there. Okay, the particles are hitting, the pressure has increased. Let's see if anything happened with the wall collision. Did it decrease or increase? Well, it increased, so the particles are hitting more the walls of the container, so the pressure has increased. So that's how particles are behaving now. So increasing the velocity of these particles is as we are increasing the kinetic energy of each. So I want you to use the word kinetic energy of the particles, so that they can or will collide more often and with more force with the walls of the container. Imagine you were moving slow and then you are pushed forward with more force to hit the walls of the container, so therefore the pressure will increase. Adding more heat, as we did, until when you reach to 413, increase the kinetic energy of the particles, so they are colliding more often. Likewise, you can see them hitting each other, or frequently with more force likewise. Now let's see what happens if I decrease the temperature. Let it get cold. Look at the temperature gauge is falling. Okay, look at the pressure is also falling. So the pressure has fallen, temperature has fallen, and the particles seem to have slowed down a lot, and they are less colliding. Let's see how often are they colliding with the wall of the container. Okay, so they are colliding less. Okay, the amount of gas in there is still the same. Okay, so what we have done here is that first of all, we say that we increase the amount of matter, or in this case we increase the amount of particles inside of the container, keeping the container constant, not changing its volume, not changing its temperature. Then we went and changed its temperature, and so we add the kinetic energy of the particles, and so they started moving faster randomly hitting each other, and so pressure increase, temperature increase. Then we decrease their temperature, and pressure decrease, as well as the temperature, and the collision also decrease. Now, increasing the volume or decreasing the volume, what will happen here in the container? We are not going to increase the pressure, okay, but something will happen to the temperature or pressure when we increase this volume. So notice here at the bottom we have 8 nanometer, or that's the size of the container. Here's the temperature, and then we're going to be increasing its volume. So when I increase its volume, take note of the pressure and take note of the temperature. Look at the particles and let's see, understand what is actually happening. So I'm going to increase the volume to twice the size. That was 8. Okay, can only go to 15. So pressure has drastically decreased. Temperature still there. Okay, let me see what's happening with the collision amount. Okay, collision is there, pressure has decreased. So what can we say? That when we increase the volume of the container, the pressure decrease, and so the overall, or the particles, will be hitting the walls of the container less often, or they will be hitting each other less often too. Okay, what happens now if I should decrease the volume of the container, keeping that amount of particles? Look at the pressure. So I want to decrease the particles to 5. So pressure has increased, temperature we're keeping it constant, and the collision with the walls of the container has also increased. Okay, why? When we increase the volume of the container, there was more space for them to hit the particles. When we decrease the size of the container, there was less space for particles to hit the walls of the container. There was more space for the particles to hit the walls of the container, thereby increasing the pressure on the walls of the container. So we have covered here 3 main points. Okay, and just basically the characteristics. So the 3 things here are that after changing the number of molecules, changing the temperature, and changing the volume, there was a behavior change with the gases. The pressure increased or decreased. Okay, this will bring us now to 3 gas laws, which we will be looking at. Okay, so having seen this now, you have a practice questionnaire at the bottom, or you may say a worksheet, a digital worksheet to be more precise, where you will be answering questions based on what we have seen. At the same time, I want you to go and download this application so that you can work it at home and to help you see or experiment some more. Eventually, we'll be looking at this ones here in specifically pressure, increasing or decreasing pressure, increasing or decreasing volume and then temperature, or temperature and volume, or simply nothing. We are not worried about these ones here in particular. We just wanted to see what would have happened. So look at the pressure. I'm going to increase it and the pressure falls drastically. I'm going to add on some more heat and the pressure starts to increase because the particles start getting much more kinetic energy. So that is how particles behave. Okay, so that is the basic introduction to particles.